So hi everybody, welcome to the second of our 3 videos with Kelvin from NILG.AI. Do look at his YouTube channel and also look at the first part of this 3-part session. So let's crack on. So in terms of the data, we mentioned there about how much data people have, and you've got some great videos on how much data do you need. I recommend people come to your channel and see those videos about how old your data is or how much data you need. So in terms of moving on to the data, and we'll come to that how much later on, but what is training data? We hear training data a lot. So what really is training data?
Okay. So we mentioned AI. Inside AI is machine learning. Okay.
Mhm.
And the way the machine learns is with experience, right? So with more evidence that it can see and understand, when this happens, then this other thing happens. When this happens, then this other thing happens. So in machine learning, we have like 2 stages in most systems, in most machine learning systems, which is the training stage, where where it's basically adjusting the model, it's basically processing all this evidence and finding the patterns between the inputs and the outputs, okay? Or what we observe in the world and the actions that we should take. And that training data tends to be like your past historical data that you will use as evidence to get a better model, okay? And that is basically the training. And most machine learning models oftentimes have like 2 stages. They have training, and then they have the prediction time or the inference time. And they don't keep evolving as they produce inference. Actually, they are frozen. They are not evolving as they do inference. So it's like they have the training data, and then they have inference time where the model is fully static. For most machine learning models, there are a few exceptions, and the exceptions are not necessarily in the most complex ones, are in the simplest ones, like nearest neighbors and collaborative filtering for recommender systems. Those evolve because those depend on the data that is on the database.
And having that, looking at the live data, so the recommendations of the late,
Exactly, but most of the other systems do not evolve that fast. Even
That's
LLMs.
a really interesting one, because I think a lot of from the governance side, one of the flags people are raising is got to be very aware of, and we'll talk about this later about how models and data can travel. I'll throw in this question: supervised and unsupervised models and training. Could you just explain the difference in those?
Yes, for sure. In supervised models, we are basically providing 2 things: the inputs, so the evidence, and the expected output that we want to observe for each one of these inputs. Okay.
Yeah.
For example, I'm telling it, this patient here with this X-ray has cancer, and this one doesn't. Okay. And this one with this colposcopy or whatever endoscopy modality has this disease, and this doesn't. Or this patient bought this product and this patient didn't buy the product. Okay.
Yeah.
And so we are providing both the questions and the answers. Okay. Expected answer. In unsupervised, we are not passing the answers. Okay. The goal with unsupervised learning is compression. It's compressing data. Okay. Why? Because if you have to compress data, it means you are capturing the general patterns of that data. Okay. So you are capturing like the high level information of that data, and you are getting rid of the noise. And there are many reasons why you will want to compress the data. For example, if you want to understand your customer base, you compressing, and it's what we call customer segmentation or clustering, right? Where we are basically taking all our customers and compressing them into 3 buckets that we can see, and we say, hey, we have the high-paying customers, which are on this segment, and we have the low-paying customers that we have in this other segment.
So you're using compressing in a different way to the way that say I might use it in that sense. So can you just tell us about what you mean exactly by compressing the data in that sense?
Yeah, I'm meaning putting this whole amount of data inside a model. Okay. That has a lower capacity, and by capacity, it's like the amount of information it has explicitly.
While keeping those relationships. And fantastic. So we talked about inputs as well. So everyone's looking at LLMs at the moment in particular, and there's a lot of discussion about we'll talk about the attacks that can happen later on as well. Just let's get inputs and outputs sort of established right now. So what actually is an input? What actually happens to it? And I've got a follow-up question on it. But so what is an input, and what actually happens to it when you pop something in?
Okay. So remember, I say AI is about sensing, understanding, acting. The sensing part is the input. It's what you realize. And when we think about AI in terms of prediction, in terms of producing a prediction, just let's play this game, for example. I'm becoming a second-time father in 2 months, right?
Oh, congratulations.
So before we have an ultrasound, if I had to guess the gender of my kid,
Yeah.
it would be like flipping a coin, right? We wouldn't
Right.
know,
Yeah.
right? Because we don't have any relevant input other than the shape of the belly of my
Yeah.
wife or the
Yeah.
position of this,
They point out that way or sideways that way. Yeah,
exactly, like
exactly.
these
Yeah.
kind of things that older people tend to say. And it's a low quality input, right? Something that
Mm,
do not allows you to know the gender that well.
mm,
But if we see an image of an ultrasound image, right,
hmm.
we can have a better input for our prediction of the gender.
Yeah.
And it's not 100% accurate or 100% perfect at some stages of the pregnancy, but it's like a better evidence of
Mm,
what's
mm.
going to happen once we get the baby, right?
Yeah.
So the input is the evidence that you have to support your prediction.
Right. Right.
Okay, and people tend to focus on improve the modeling part, but the most benefit comes from getting better evidence and getting better input, getting better data. And that is
Yeah.
why the world is drifting from model-centric AI to data-centric AI, which is put more effort on improving the data and not so much on improving the model. And then we say also the data doesn't matter. What matters is the business. And it's like making it make sense to the business and do business-centric. But then what happens with the input? Here I want to separate two things.
Yeah.
One is the AI model, and another one is the AI system. Okay.
Okay.
For the AI model, we have two stages: training and inference. For most of the cases, for 99% of the models, that will be the case. What happens with the input during training is that the model is compressing this into a model. Okay, so
Hmm.
the information can be there at some point. The training
Yep.
information can be there hidden. There are some works proving that you can extract some form of that data. Okay.
Hmm.
But once the model is trained, nothing happens. So the input just flows, get compressed, and get a prediction. Okay, it's not like
Right.
it's stored out there for most models, except for like recommender system stuff. For most models, the
Yep.
input doesn't get stored in the data in the model, and this is the case for the AI model.
Yep.
But then, of course, we need to understand that the AI model doesn't live alone. It's inside a system, and that system can be storing the information. And when we say,
Right.
do not pass information to ChatGPT, the free version, because they can be storing that information.
Well, this is then a follow-up question because there's a lot of conversations around. So, for example, one company put its own proprietary source code in, and it was
Yeah.
being spewed out. Another company,
I think it was
would,
Samsung, right?
yeah, I didn't, yeah, yeah, and then others are sort of putting in personal data, and
Yeah.
and I read a survey just recently that something like 2/3 or more of organizations have banned
Yeah.
staff putting personal data and confidential information IP into models, and so that's
Yeah.
about the system then retaining
It's
it.
exactly. It's more about the system because, of course, if we get very technical and we say the model is not storing that
Yeah,
information, but the
yeah,
system as a whole, the company around it, the product around it,
yeah.
can be taking information, storing that information, knowing how you reacted to it to get feedback. So that is why it's important to review terms and conditions, privacy policies.
Mm,
But
mm,
that's not just for AI products. It's the same for a social network, right?
mm, mm, mm.
So a social
Yes.
network in general, doesn't have to store the information or not, or a chat messaging platform,
Yeah.
it shouldn't need to store the
That's a
information.
superb point because that also, I think what's really helpful is we all know how to think about social media and using it as governance people. And so it is true that it's a lot of the same first principles when you look at it, and the things that
Yeah,
we're used to thinking about all come through. And that was really wonderful about explaining about model and system. Thank you very much. So how risky is it then with putting personal data and information in, really doing the due diligence? It's looking at what that AI system is and whether it's actually retaining it in there. And it's like more likely in things like recommender models and less likely in some other models
exactly. Yes.
or
For example,
systems.
exactly. Modeling part, I will say in recommender systems, the core of the modeling part is on the recording the interactions. So
Yeah.
everything is stored. Every click you do on Amazon most likely is stored.
Yeah.
In systems, I will say how risky it is. It's I will say it's a matter of incentive, right? So AI companies have more incentives for storing the data than non-AI companies
Mm-mm.
because their models get better with data, right?
Yeah.
So as a system, I will say you will see more AI companies storing all the data that you pass into them. So I will say is in principle as risky passing private information to an AI company than to a different company.
Yeah.
But there is a difference on the incentives that they will have to prefer to store this information. So AI companies will want to store this information to improve their models. So they have more incentives to give you easy ways of giving the data to store it and improve the models. And that is what, for example, ChatGPT in the free version, they can use all the data that you pass it to improve
So
their
that's
models.
basically they've done their training data to get their model, and then they're using the data that's coming through as almost like traveling training data to keep it going and keep
Exactly.
that process going. Which brings us
The
to the
free version.
outputs really, really nicely. So how are the outputs then? We've sort of talked about this really, but if you could just recap then you get the input, but be that a scan of a patient or be it an input into an LLM. And then how are the outputs then created? And what is hallucinating? Is it in every single type of AI? Is it only in a particular type? Can it be eliminated?
Yeah. So AI models are good at doing interpolations. I'm not sure if interpolation is a too technical word
Oh,
or
well,
not.
if we explain it, it's going to be great. Yeah.
Okay, let's say you have a data point here and you have a data point here. AI models are good at knowing what will happen here, okay, in
Right.
the middle, okay?
Yep.
And the way these models are built are in a sense that they are good at doing interpolations between the data they saw and the data that will get shown,
Yep.
okay? And this is a probabilistic game, okay? It's
Yeah.
not like they know it will be here, but it will be around here.
Yeah.
Especially
On
with
a
LLMs,
graph. Yeah.
exactly. It's like a probabilistic game. So how much you let the model deviate from this main assumption is what gives you more creative answers or less creative answers, okay? In the case
Right.
of LLMs. Because then LLMs are just playing a probability game of what is the most likely answer,
Was it?
the
Yep.
most likely word after this word,
Yeah.
and then they play a certain set of randomness. The main issue with hallucination and why this is also the case for previous models and not just for LLM, is what happens when you have this point, and instead of passing a point here, you pass a point out of the training data, out of the
Right.
kind of things that it tends to know well.
Yep.
Okay. The machine won't say, I don't know. And we have a video that we call allowing your models to say, I don't know, or your model has the right to abstain, something like that. I think it's
Right.
your model has the right to abstain,
Fantastic title.
which
Yeah.
is AI models are not prepared to say, I don't know. Okay. They just
Yeah.
will do their guesswork.
Yeah.
Okay.
Yeah.
And sometimes where your data is too far away from the training data, they are not capable of interpolating a reasonable answer.
Mm-hmm.
And then they just predict whatever it comes out to that model, for
Mm-hmm.
example. And this happens with all models. Let's say that you have trained a model to predict the gender of a baby on an ultrasound image, right?
Yep.
And then you pass an image of a cat. Okay.
Yeah.
Then the model will say boy or girl. You know,
Right. Right. Right.
it won't say this is a cat.
Yeah.
Okay.
Yeah. 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 It
And
got you. Yeah.
it's a form
That's
of hallucination.
this is
So,
such a great chat because there's so many reminders to us of the limitations of it, and it's
yeah.
so easy. Even though I'm quite a cynic about, I mean, I did an engineering master's back in the day, but I sort of, I love the machine intelligence rather than artificial intelligence, and this sort of dehumanization of it to understand it more. But that just what you said there, it really brings it home. Just you know, people, it's so easy to trust it, isn't it? It's just
Yeah.
so easy to bestow it with more power.
Especially because LLMs are more general models in the sense that
Yeah.
they sound smart on the type of topics that you and me could talk about, right?
Yeah.
They are maybe not good at analyzing a time series, right?
Right.
But we are not good at that either. So we don't get mad when we see a time series forecast getting out of the,
Yeah.
of the general range, right?
Yeah.
Um, but with LLMs, when we write something and it's out of the typical, first of all, what something falls inside the training data? We don't know because we don't even know what type of
Mm.
training data was used. And we don't know what is the range of tasks that these things can handle well or not.
Yeah.
And as the universe of training points becomes larger, the frontier between what is inside and what is outside the training data is more blurrier,
Yeah.
right? With
Yeah.
X-rays or ultrasounds or this type of more
Yeah.
traditional
Yeah.
information
Absolutely.
is clear. Like this is an image of a cat. It's not, so it shouldn't answer well. But with text, it's like more tricky, like
Mm,
should the model be able to handle this request or not?
And I think that's
Like,
also an interesting one there, that different forms of AI or model systems, etc., are better for different purposes. So it is something to, although a general AI is by definition to deal with a broad range of things, it might be that there's a different type of AI or tech to use that could be better for a particular purpose. So we talked a bit about shifting, about the training data, for example, and about the model. But let's talk about it a bit more, because there's quite a lot about how, with the security attacks as well, which we'll come to later, about people being able to trick AI into giving different responses, and to actually change the type of response it gives. I mean, there's another example that's sort of relevant, where there was a car company that had a chatbot, and it was
yeah,
tricked to give recommendations that the other car company's trucks were better than its, and all this sort of thing. And then they had to put in place guardrails to keep it in a particular place. So I suppose, how many different types of shifting are there? It sounds like really you've got that original training data is pretty set, the model's set on that. And then as you get different training data and inputs, if it's of a type of model that is looking at continually changing and looking at that, like recommenders or general, for example, that you can do this shifting. Is it the model shifting? Is it the data shifting? Could you take us through that and how we should think about it?
yes. So let's assume we are not retraining the model, right?
Right.
So if we are not retraining the model is not shifting, it's static, right?
Yep.
What happens with LLMs is that we are shifting the evidence the model has to predict,
Hmm.
such that we put it in a different area. So remember the 2 points,
Yep.
and we want an answer here,
Yep.
interpolating. What we do is we say, let's say that now my evidence is around here, which is an area that
Mm-hmm.
it will be more likely to answer a certain type of
Yep.
thing. Okay,
Got you.
so it's basically, when we think about this type of attacks on LLMs, it's not like we are shifting the model. It's like we are placing the evidence on an area where the most likely answer will be what the model tends to
Fantastic.
say, right?
Right.
Because it's a
Right.
probabilistic game. So that's shifting the evidence, right?
Yeah.
But then let's assume again that the model is static, okay, and we are not retraining the model. Another thing that shifts is the universe, is the world around us, right? And this, so if the model is constantly evolving and the model is not being retrained,
Hmm.
then its predictions will be out of the expected
Right.
answers.
So
Probably
the
beyond,
outputs can shift in terms of their
yeah,
accuracy and
exactly,
dependability.
exactly, because the variables around the world change, right?
Yeah.
And
Yeah.
that is why machine learning is so important in AI nowadays, because it allows the model to keep evolving and retraining as the model evolves. But then there is actually a very nice issue with this shift with this. So there is a debate, right, on whether or not we should use copyrighted data
Mm.
versus
Yeah.
public domain data for training LLMs. And some people say, we shouldn't use any data that is copyrighted, but that will only leave us with two paths, which will be having consent from these authors
Yeah.
to train the models, or only using data in the public domain. And data in the
Yeah.
public domain is like at least 70 years old
Yeah.
or hundreds of years old.
Yeah.
Okay. Now think of what will happen if we rely on a model that was trained on data from 70 years
Mm,
ago,
mm.
or from 100
Yeah.
years ago, because the model will be static on that point, but the world has shifted over
Yeah.
these 70 or 100 years of
Great example. Yeah.
evolution, right? So there is a big so if we go on this route that we cannot use copyrighted data to train AI models, and we can only use data in the public domain, I believe there is a big risk that these models will get very biased toward things that were completely normal 70 or 100 or 200 years ago, like slavery, like racism, or like
Yeah.
racism, or a lot of different things, right?
Yeah.
So
So that's an
considering,
interesting. Can I just jump in actually with a question there? Because if you've got a model that's assuming it's not going to be dynamic and it's going to be a static model that's been trained on a certain set of data, then that brings in versioning and updates, as you say, the world does move forwards, it brings through deprecation of outdated models, and treating AI very much like any other tech, like Windows goes through all different versions or what have you, or your Mac OS goes through different versions. And then presumably, how do you look at AI in terms of almost that model versioning or deprecation of stuff if it's going to be a static model like that?
Most people are just retraining the models continuously as they get
Yep.
more data. Not as part of the inference, but as a separate process that is retraining the models
Right.
without the proper guardrails, okay? Without the
Right.
proper control. And it's just, we have a new model, just put the new model in production, and they don't keep track of the KPIs or the metrics before putting the model in production. There is a whole area in AI which is called machine learning ops, MLOps, that deals with this operationalization of machine learning models. And it's like DevOps, like, when you make
Yep.
sure that every new release passes a good set of tests, and, quality control, quality assurance. There is this area which is MLOps, which deals partially with this versioning. What is a potential problem here? Before the current trend on LLMs, most AI models were built in-house. Okay, so you control the versions. Okay, and basically you understand that this version works well, and you freeze this version, and you generate all predictions with this version, right?
Yeah. Yeah.
Depending on the AI model you are using, they can be retraining it on the background, and some things that you did, I don't know, 2 months ago are already deprecated because the GPT-4 model now doesn't allow you to do that because they shifted the model, because they retrained the model.
Right.
And unless you use a frozen version, then that could happen, and you need to put certain, checkpoints, let's say, in production to make sure it's not breaking. Those changes are not changing.
That was part 2 of Demystify AI with Kelwin Fernandes. I hope you enjoyed that as much as I did. And do check out part 1 if you haven't already. Do like and subscribe to Privacy Kitchen, and we'll see you in part 3.